Hi, welcome to R&AC Academy. My name is Ram Prasad. Let me give a small brief about me. I did my masters in R&AC and then I worked for 25 years with the various organizations involving in product development and technology innovation functions. I had 5 patents filed on my name. Out of my passion, I transitioned into teaching. Presently, I am into coaching GATE and IES aspirants on R&AC subject. I also conduct workshop on R&AC systems, faculty development programs, etc. for the engineering colleges. Recently, I conducted webinars for the members of ISHRE and ASHRE. Coming to this program, I am presenting here with a series of lectures on refrigeration systems for the benefit of the students and professionals. I believe these lectures will be of great help and learning to all of you. This is the 6th lecture in the series of lectures on refrigeration systems. In this lecture, I will discuss various COPs which we will be dealing with in this subject. Let me start with Carnot COP. And we will be considering the same problem that we were discussing in the previous lecture. That is, to find the Carnot COP for R134A refrigeration system working between 40C and minus 20C. We all know that the Carnot COP is computed using the operating temperatures only. And hence here it works out to be 4.22. As per Carnot theorem, the Carnot COP does not depend on the working fluid at all. Here, an interesting question comes to the surface. That is, will the COP value be same if we do the computations using R134A property data on Carnot refrigeration cycle? I repeat, on Carnot refrigeration cycle, if we do the computation using R134A property data, will the COP value be same? And the answer to that question is yes. Then, an auxiliary question comes to the surface now. That is, will the COP value be same if the computations are done using the property data of different refrigerants, but working between 40C and minus 20C and on Carnot refrigeration cycle? The answer to this question is also yes. The basis for this answer is no doubt the Carnot theorem. But we all have one question in our mind. That is, why should we believe this? This is a perfectly valid and a logical question. There is no doubt about that. So, I did those calculations and I am here with presenting the summary on that. This is the performance computations done on Carnot refrigeration cycle using R134A as the refrigerant. We could see that the COP in this case comes out to be 4.22. So, the answer to the first question is validated. Similarly, I did the performance calculations for Carnot refrigeration cycle using R22 as the refrigerant and then R12 and then ammonia. In all these cases, the COP turns out to be same 4.22. Hence, we can now believe that the Carnot COP does not depend on the working fluid at all. It depends only on the operating temperatures. Let me now summarize various COPs which we will be encountering in this subject. Let us start with the Carnot COP. The most important aspect that we need to understand about this number is that it cannot be achieved by the VCR cycle under any circumstances. It is just a reference number, and if anybody is claiming a COP greater than Carnot COP, then we can declare that proposal as invalid without any further investigation. The next one is the COP of ideal VCR cycle, which we had computed in the previous lecture as 2.1 for an R134A refrigeration system working between 40C and minus 20C. The significance of this number is that it is theoretical COP, meaning if everything is happening exactly as per the definition, then this system can give a COP of 2.1. Hence, the physical VCR system working between 40C and minus 20C using R134A as the refrigerant cannot have a COP greater than 2.1. In other words, the COP of the actual VCR system in this case will be less than 2.1 only. So far we discussed the COPs which are not possible to achieve. Then what is the COP that is actually possible to achieve? Let me give an interesting perspective on that. Let us say we have an electric power source and we are supplying power to an electric motor. We all know that the function of electric motor is to convert electrical energy into mechanical energy. It gives rotary motion as its output. Then this electric motor supplies this rotary motion to a mechanism. What is the function of the mechanism? Mechanism converts the rotary motion into a required format. For example, we are having a reciprocatory compressor. Then this mechanism will convert the rotary motion into reciprocatory motion. And then it supplies that reciprocatory motion to the compressor module. The actual work upon the refrigerant will be happening in this compressor module, and the compressed refrigerant will be delivered into the refrigeration system. Let us now put some numbers into this. Let us say we are giving 1000 watts to the electric motor. If the motor efficiency is 70%, then only 700 watts of rotary motion will be supplied to the mechanism by this electric motor. And if the mechanical efficiency of the motor is 90%, then the mechanism will supply only 630 watts of reciprocatory motion to the compressor module. And if the isentropic efficiency of the compressor is 80%, then only 500 watts of work energy is supplied into the refrigeration system. In other words, we are paying electricity bill for 1000 watts and we are getting just 504 watts of use out of that. With this discussion, let us get on to the COP actual. COP actual is equal to COP ideal multiplied by efficiency of motor, efficiency of mechanism, and finally isentropic efficiency. Is this list exhaustive? No. If we are having some more inefficiencies, all of them are to be included in this. Then how long we will be computing this COP actual? It's time taking and also complicated. That's why COP actual will be computed like this. RC by power n. RC is mCp delta T, where m is the mass flow rate of the medium, Cp is the specific heat of the medium, and finally T out and T in is the temperatures of the medium at the evaporator in and evaporator out. And then power input is the wattmeter reading. Using these two, we will be computing the COP actual. Okay. With this lecture is completed. In case you have any questions, doubts, etc., please feel free to write to me. The next topic is influencing factors on VCR cycle performance. See you then. Thank you very much.